Record it. All right, so chapter 10 about security and network design. We're going to look at a few things that you may be familiar with. So what do we got here? Security precautions. To be honest, this lesson doesn't really talk about designing networks so much. It talks about the tools that you would use in designing a network. And so designing your network for your security, that would be something that you would add on to this. So there's some things that we think about with our switches, things that we think about with our routers and our actual hardware firewalls, that type of thing. We do talk about authentication authorization at the end of the lesson. So those are the objectives that we're supposed to talk about. We do talk about access control a little bit, right? And the wireless network security issues there really have a lot to do with your WEP, WPA. You may have heard of those. So we just talk a little bit about the history of those and where we are with those and how that affects our security. Okay. Proxy servers. I've got a slide or two about proxy servers, access control lists, firewalls as a specialized device, as a special physical device that we put on our network between our routers and the outside world, kind of thing, and other options that we have. So let's get into it, shall we? So we have this concept of a proxy server, and there are two different types of proxy server we're mentioning here, proxy server and reverse proxy. The idea is to put a device between our clients, that would be a proxy server, that are trying to get onto the network, into the internet, etc., and the rest of the world. We put a device between them. So instead of connecting directly to other devices outside of our control, which could lead us to a security problem, we put another device in there that controls that flow. So we don't connect directly to the outside world. We go through the proxy server and then to the outside world. And so the proxy server has a lot of benefits, and that's not, security is one of the benefits. Another benefit that it has is that you can use a proxy server to sort of get around ISP firewalls, etc. So you can do proxy server here in Qatar to sort of get around some of the issues that might happen with Rito trying to sort of filter your work. So there's that, but it also provides that security to you, because the proxy server is going to probably filter the traffic, and it won't allow outside devices to know. They won't be able to see the IP addresses of the computers inside your network. They'll only be able to see the IP address of the proxy server. So the proxy server is kind of standing there as a well, it's proxy. Proxy means somebody that stands in for somebody else. It's standing in for your server with its IP address. Your IP address is back here, or your client, and the outside world cannot see your IP address, which is kind of good for you. So as it says, it manages security at the application level layer. The application layer there, we're talking about layers in the OSI model, right? So your application layer was the top layer, right? So it's managing security at that layer. Now, for security to work really well, we'll see this in this lesson, we want to use all the layers, or as many of the layers as we can. We use multiple layers in our security. So proxy server is there. Prevents the outside world from discovering our address, but it also lets us work on the outside world with and sort of get around some things that might be put in our way. Now, the reverse proxy, as the name suggests, reverse proxy is kind of the opposite idea. So how that works is you put a proxy in front of servers instead of in front of clients, and it provides services through its own network, as it says, but the server is protected in its identity. So you could use a proxy server if you're a big company and you had multiple servers, right? So the proxy server would be the place where everybody went to, and then that might be farmed out. So in addition to adding some security, so that means that, so you're a big company, you know, Amazon or whatever, people are going to get to your servers through the proxy server, and the proxy server will direct it to as it wants. So you can do a bit of load distribution as well, so that we're not sort of overloading any one. So that's the idea with multiple web servers can be accessed through the same public IP address. And so that can add some sort of efficiencies for big companies, etc. So here's the diagram. I don't think I have a diagram for the the reverse server, reverse proxy, but we've got one for a proxy server. And so you can see that we've got these clients in here, and we want to protect them from people who are out in the outside world. If they want to connect to anything in the outside world, they go through the proxy server. The proxy server IP address is the only IP address that is seen by the people out on the internet. And yeah, so that works kind of well. Access control lists. So basically, what you're going to do here is you're going to say for specific ports on your router, you're going to allow different access for different types of users, or just different access. All right. So I mentioned it a minute ago that we want to use as many of the OSI layers in our security as we can. So here we were talking before about the proxy server was using the application layer. So here at the ACLS, we're using the network layer and the transport layer. So network layer is going to work with your IP and your ICMP protocols. Transport layer with your TCP and UDP protocols. So we're basically getting inside the packet. Well, we're inside the packet when we're looking at the application layer thing, right? But we're looking at those headers that are on the packet. And so based on, they're right there, very easy to get to. I mean, every frame has its frame header and then its packet header. And so we can, based on what is in those headers, you can have a treatment of what's going to happen to that traffic through the access control list. So the router is going to receive that packet, and it's going to examine the packet. It's going to look at those headers, and then it's going to check to see, what the permission should be, depending on the source and the destination of that packet. So each interface on the router will probably have to have a different access control list. The access control list, as it suggests, is going to be a list, like a database of allowed connections. And so what you've got is you've got an incoming packet coming from outside of our network, and we're going to have some kind of a test on the access control list. If that test produces a particular result, you'll just deny that packet and it's gone, right? On the other hand, that test is passed, and then we're going to sort of forward that. We got two choices here. If it's passed, then we can go there, right? If there's a particular thing on that test which is denied, but if we're not sure, we're going to say no, then we're going to do another test. So we can do multiple tests in the access list, checking multiple access lists to eventually either allow or deny access to the network of that particular packets. So it's at a packet list. The lists are at a packet level. So we've got some commands that we can use in our router setup. So for example, we have a command access list. Then we have a access list which we've called ACL2. And what we can do is we can have a command which permits any ICMP traffic to sort of access that particular router port. Now, on the other hand, we've got another command here, which we're only allowing particular IP addresses to traffic to particular IP addresses on the network. So you can say that, right? So in our access list, we're saying that any traffic from this particular host will be allowed to go to that particular host. And so we can do that in an access control list. Now it mentions there that it does control it does affect the performance. Yeah, we're adding extra work to the network, right? So the router has some stuff happening before it forwards the packet. So a router receives a frame and strips off the frame header, and then looks at the packet address, the IP addresses, and then forwards it, puts a new frame header on it, and forwards it out the right port, depending on that. But if we're using an access control list, then it's got a little bit more work to do, right? It's gonna look at that information there in the header, and it's gonna check the access control list, and only if there's no problem coming from the access control list will it be forwarded. It might drop the packet, in other words. So that's a little bit more work. And so that's going to take a bit more time and a bit more performance. So that's what we noticed, right? So we got a bit of a trade-off here between performance and security. And that's a very, that's basically the trade-off that we typically have is, yeah, we can have more security, but our system will be slower, or our system will cost more, or both. And so that's the thing that we have to consider. So a firewall, typically going to be a hardware device that we're going to place between our the edge of our network, so outside our router, and the rest of the world. And so as it says, involves some hardware and software combination. We're going to put it between our networks, between the edge of our network and the public, or between the edge of our network and some other network. So there may be some features of a firewall that are integrated into other hardware on our network. Especially nowadays, we have very powerful devices on our network in our routers and our level 3 switches. But we often have standalone firewalls as well. I think we got some diagrams of those. So here we have a diagram sort of showing that on the edge of our network, we've got a firewall. Now, you're going to see some more diagrams in this lecture, which show a sort of more detail. So we got some more stuff going on here at the point where we have the firewall. But just the general idea here is we got a firewall between the outside, which is a risk, a danger to our network, and our network itself. So the idea there, the firewall, is we have a device which is able to sort of look at traffic that might come in that might be dangerous, and also to look at traffic that might be escaping from our network to people that shouldn't be seeing that traffic. So our firewall does both those things. And so here's what some of those devices might look like. Some firewall devices. And here's kind of what they do. So as it says there, the simplest firewall is just going to filter the packets. It's going to look at the header of the traffic packet. And it's going to block traffic going out. And it's going to block some traffic coming in. And so it can be pre-configured to specific security threats. So in other words, we know of a particular type of threat that's out there. And so we configure our firewall so that that particular threat doesn't have access to our network, or that particular type of traffic cannot escape from our network. And so our network administrators are going to customize that. So as I mentioned in the previous sort of slide, your firewall is working in both directions. It can be stopping inbound traffic, but it can also be stopping outbound traffic coming from our LAN that we don't want, that we can do things inside our LAN in privacy without that sort of escaping out to the rest of the world. Obviously, we don't want that. So we mentioned here that firewall is working with packet filtering. So that's good. The packet, of course, has a header. Your header of your packet is your IP addresses, source and destination. So it's going to look at those. It also is working in the TCP header, which will be inside the. You remember how a frame looks? You get frame header, which is your MAC addresses to and from. Then you got your packet header, which is going to be your source and destination IPs. And then you got inside that, you got your TCP, right? And so, that level TCP or UDP header. And so it actually goes and looks down as far as that, right? Can look into so basically examining inside the packet to check your TCP header and see if some transmissions can be stopped there, right? So you might want to, for whatever reason, you might want to block UDP. UDP would be like streaming, so you could look at the types of packets. You could use your firewall to block people watching YouTube videos, because they're going to probably come with UDP or ICMP. People might be trying to ping things inside your network, you know what I mean, and sort of find out where they are and what's their. So that you can set up your firewall to block that. You can do port blocking. I want to talk about port blocking here. I'm not talking about physical ports, right? We're talking about the port numbers, which refer to protocols. All right, so that's at that's at a protocol layer. So, for example, you might want to block port 80, which would be your HTTP or something like that. Okay, so you can do things like that. And there's a bunch of other things that we can do with our firewall, encrypting, centralized management, etc. I'm not going to go through all of those. Monitor packets, according to existing traffic streams, etc. Yeah, I think that's kind of self-explanatory. All right, so the next 2 points that are on this slide is, so you imagine you got a firewall, all right, that's giving you some protection. So what if we wanted to add more protection to it? Okay, so basically we're stepping up our protection on our, with the concept of a firewall. So above the basic firewall concept, we have this concept of a unified threat management. So basically that just means we're adding functions to our firewall. So multiple layers of security appliances, but it does require a lot of processing power. Even above that is our next generation firewalls. They have a lot of built-in features, can monitor and limit traffic, as it says, adapt to the class specific. So basically, the point that you should get out of this slide is that we've sort of evolving this as we go. And actually, you'll see that when we get to the wireless network stuff, is that how we've evolved our security as we go. So yeah, we started off with our basic firewalls, and they just sort of worked with the packets, right? We're filtering packets. And so basically here, what we're saying is, but we can add to that. We can add a lot of extra features to that. And so we came up with this unified threat management, which is going beyond sort of just filtering packets to doing these other things, many other multiple layers of security, and next generation firewalls, which have built-in AC application control, as it says. All right, so firewalls can go wrong. What you should get out of this slide is that mostly when the firewalls go wrong, that's a configuration problem, right? So that's a problem for you because you're going to be the network administrator, right? And so you will be called to look at that. The firewall's it's blocking the wrong traffic. It's not blocking the right traffic. Okay, that's a configuration problem. And so that has to, if you're blocking everything, things are going to run slowly, right? You could set up your firewall so it just, as it says there, it just sort of grinds things to a halt. On the other hand, you can make it really lenient, as it says, and things can go pretty quickly, but then you're exposing some risk. And, risk is kind of like having an accident when driving a car, right? We all like to get there faster, but if you go too fast, then you end up taking a long time because you have to stop off at the police station and, have to stop off at the car fixing place and all those things, right? So haste does make waste. The next 2 ideas we've got here is about detection, as it says there, intrusion detection. Somebody is sniffing around trying to break into your system. And how do we know about that? So we have these systems that one is called intrusion detection, and then the other one's called intrusion prevention. They're kind of related, but they're kind of a little bit different. So let's just talk about that. Intrusion detection. So as it says there, you're going to have a device or an application or feature. Could be any of those things. Could be attached to a switch or a router or a firewall. But basically what it's doing is it's monitoring the traffic and it's looking for somebody sort of sniffing around, trying to sort of break into your traffic. Now, the thing is, we actually kind of know what hackers have done in the past. And so we apply that knowledge that we know, well, this is one sort of exploit that people have done. This is one way that they've sort of been sniffing around and getting into people's networks. So we know about that, and we sort of configure our intrusion detection system with that. So it knows particular things that hackers are trying to do. It looks for that particular pattern of activity. And if it finds that particular pattern of activity, it's going to do a report on it. That's your intrusion detection system. So as it says, it's going to look for statistical anomalies. When we say statistical anomalies in the pattern of the packets as they're arriving, what's going on here? If we see things that we got some kind of repetition and things that somebody's trying to do some kind of brute force attack on our network, so it can sort of indicate that those things are done. Now, as it says, it might look for a signature. Last week, some hacker in Russia did these 5 steps. Okay, so that's a particular pattern. And so we see that pattern, and we a signature pattern. I mean, it's not just sort of a statistical anomaly. They did it like this. And so we've got that, and we can sort of see that if that's happening on our network. So as it says here, we've got two different kinds of IDS implementation. You can implement it on a device on the network, so your network devices, or you can, as a standalone device, or attached to a router or switch, you can implement it, or you can implement it on your hosts, including your servers. So that is, you can put it as a bit of software. So we've got two different kinds, and we refer to them by those two different names. Your HIDS is going to be running on a host, so like a server or a client. It'll be doing things like checking if there's any sort of attacks on particular files, etc. Your NIDS, on the other hand, is going to be running out there on a network device. As it says there, it might be in the DMZ, the demilitarized zone. Canadians don't say Z, but Canadians also don't spell color with CLLOR, and neither do British people. The standardization in the computer industry seems to be on American spelling and stuff like that. So you'll hear this called DMZ, because that's how the Americans say it. So demilitarized zone. A little bit of history on that. I don't know if you're interested. I don't know. We'll talk about that. DMZ just means a place which is between us and the other world. We actually set up, there's a third place, right? There's the outside world, there's us, and then there's this third place. And the third place is a demilitarized zone. Why do they use the term militarized? Well, I don't know. I suppose it's something that people are familiar with, particularly Americans. And a lot of this stuff came out of San Francisco, right? That's a lot of the IT industry. That's where Cisco is, which is why it's called Cisco, right? Cisco, Frisco, San Francisco. So this is a way of thinking that they have, I suppose. Now, the idea of port mirroring is that you can, as it says, you can send basically a copy of the traffic that's coming to your port to another port, and then that port can sort of keep track of that, do some monitoring on it. So that's IDS. IDS is monitoring. It's sort of checking what's happening, some strange traffic that's coming to our network, and it's producing reports saying, this could be this could be this, that kind of thing. So, but that's all it does. All it does is monitor. Then it's up to somebody, like the network guy or lady or whatever, to sort of act upon that. So it's you got your IDS device. It's going to produce you some nice reports. You're going to look at the reports, and then you have to decide what you're going to do, right? What are you going to do to sort of stop this traffic, whatever? That's up to you. And the other point there is that it kind of is hard to sort of get it exactly right. And you could be recording some things that are actually not a problem, but just because they statistically look strange, that, it's been flagged as a problem. So your IDS device is good, though, because it's going to give you these nice reports, but you really need to have somebody trained. Your IT person, your network person needs to be trained to know what to do with that. Right. So the next idea is your IPS. So your IPS, we changed the word detection to prevention. And so it kind of works a bit like the IDS, except it actually acts on its own. So it's sort of been programmed that when particular types of patterns of something that is identified as an intrusion occurs, then it will act upon it, throw out the packets, basically, stop that. So it's going to be able to detect a threat, and it's going to be able to act upon it and sort of, as I say, throw out that and block that traffic. These terms we've already talked about. Your network-based intrusion well, we called it DS, right? So just change the D to a P. So you can, just like you did with the other things, you can have that running on your network devices, or you can have it running on a host. And so we've got some here, our network prevention, network intrusion prevention system. What do you want to call them there? Devices. that are sitting out here as network devices. They're away from our hosts. So they're protecting these hosts by standing between them. And we got one here that could be inside on our internal network. We've got one here that's actually in the DMZ. So so actually it's cut off from our network by these firewalls. You could have your system configured and running on a server. So that's why it's the host intrusion prevention system. Right, that brings us to this next topic, which I'm sure you've heard lots of times. I don't know, I assume that you have. We got these terms: authentication, authorization, and accounting. If you haven't heard of them, at least you've been involved in them, right? Whenever you connect to a network, you're going to do these things. So first, there's authentication. Authentication is basically, is the person who's trying to get onto the system, are they who they say they are? And basically you have that on your phone even, right? You know, when you go and you use your thumb and you use your face recognition and you use a pattern and you use a password, you know, so all of those things, those are authentication. It's basically, are you who you say you are? That's authentication. That's me. Or I'm the person who's trying to get in that. And now that's a little bit different than authorization. They kind of sound the same. They kind of are kind of related, but our authorization then is okay. So you say who you are, who you say you are. All right, come onto our system. But what are you allowed to do on the system, right? So you're allowed to do this, but somebody else is allowed to do something else, right? We're authorized to do different things. So our authorization is going to be what actual access do we have on that system, and it's going to be based on individuals, right? And so your counting is just going to be a record of what you've actually done while you've been on the system. So let's talk about authentication first. I'm sure that hope that you're familiar with this. Anyways, as I said, this is the kind of thing that everybody runs across just in their normal life. So you have to give some kind of authentication. Maybe you've got a local authentication with usernames and passwords. Got some advantages. It's very convenient. Backup, but it's a bit low security. Every computer in the network is responsible for securing its own resources. Imagine if all of our devices were just local. It's not that, is it? When we log in here, we're logging into the network, right? So otherwise it would be a different login on every computer, but you notice it's the same on all of them. So we're not doing that local thing. We're doing something like a setup here for Windows where we've got network authentication on the domain. And so the network administrator has set up a system which allows you to access computers all over the college. And so that can be done as a network thing. So you got network authentication going on here. And domains, as it says, so actually different users are allowed to access different domains, right? So students have a different domain than teachers. And when you log in, it's different. That must be, otherwise, you know, students would be there going and changing their grades and stuff like that. That'd be, because teachers can do that, right? We're changing their attendance records. All right, so there's just some screens from Windows domain, setting up your computer so that you're actually working on the network and not just a local login. Okay, so your network authentication, as it says, we can have secure passwords. We can do some extra things to do that. We can say that you can only log in certain times of the day. Some systems would do that, right? You know, if you're working yeah, you don't want your IT people logging in at 1 o'clock in the morning and doing strange things on the system from some other place, right? So maybe we only let people log in for 2 hours at a time. Maybe we check the IP address that they're trying to use to log in from. Maybe they've tried to log in 3 times, and so we'll time them out, or we won't allow them to log in. Maybe we won't let them log in from outside the city or outside the country. And so we can do that with IP addresses of the source. Now, of course, people are going to use their VPNs and try and spoof that, right? So that's another thing you have to sort of watch out for. What are we talking about here? So you have a privilege or a right to execute, install, uninstall software. This is a particular that here on our network. That's an admin privilege, and most of us don't have admin rights, right? So that's something that can be separate from your normal user. So, for example, you go and try installing anything on the production networks, you're not going to be able to install it. And they're using that to control you. So there's a list. It's like a database which has the user and then what rights they have. You know, they're allowed to do this, and you have read rights. And you have write rights. You can read and write. And so for most of us on a lot of this, we won't be given write rights to particular things. Role-based access control. Yeah, so the administrator is allowed to do some things, other people are not allowed to do other things. And the role separation goes with that. So basically your system administrator is going to produce groups and lists, and these people can do this and these people can do that. And, you know, we separate what they can do with the different people. Okay, so this is kind of showing that kind of a screen that the network administrator would have. They're creating a group, and then they add people to the group, and then they give them certain permissions. Single login. So the idea of a single login, I think that's what we're talking about there. Yeah. So you sign in once, but you're allowed to use multiple systems. We kind of have that, or we used to have that here. So basically, the idea would be you come into the front of your intranet kind of thing, and you have access to that, but then you have access to lots of other systems just by logging in once. So the thing is, you've used the one authentic. It's not a high level of security, right? Because, you know, maybe there's resources there that are on the border of whether they should be used or not by that person. Two-factor authentication. So like on my phone, I downloaded this app, which can be sort of coupled to the college system. And so when I log in, I have to log in with my password, and then I have to give a special code. And so this generates a special code for me. We used to use one of these little fob things that we're pushing. And so you do that with your bank. I mean, almost all banks require two-factor authentication, right? So it could be with a special number like this, or they could even send you an SIM. Sorry, a message. SMS. They could even send you a SMS message and then you the number in. So that could be a two-factor authentication. They could ask you for some bio factor. So, you know, look here and from your eyes or your thumbprint. I liked it now. I mean, I can get to all my banks just with my thumbprint, so I don't have to remember any passwords. Awesome. Yeah, if you require more than one, you could call that multi-factor. So here's something, I like this, the way that this is put. Things that you might be required in order to get authentication. So something you'll be asked to enter a password or a PIN. That's something you know. Something you have. So you give a card. Something I have. That gets me into this room. That's my authentication, right? Because that's on the system. And something you are, your fingerprint. So I use that to open up my phone. And on my phone, I use that for many apps. And, you know, as I said, all my banking apps are by the thumbprint. I'm not worried about people knowing that because they don't have my thumbprint. Right? I think I'm all right. So that's something you are. So where you are, a location in a specific building. And this kind of goes with that, right? I mean, they let me into these rooms, but they don't let me into other rooms. You know, yeah. And something you do, specific way or type of speech, I suppose. So, yeah, that would be with your bio things, right? So you could talk to it, you know, Siri, do this, right? I haven't noticed that it recognizing a particular voice. Yeah. Multi-factor authentication requires at least one authentication from at least two different categories. So you're gonna have two things, you know, thumbprint and a password, or thumbprint and that, speaking to it, thumbprint and eyes, password and some, yeah, etc. Two things at least. Security token. I guess that would be the thing that I used. I lost one, right? We had with this one and I used to wear it with me. And I got on my motorbike one day and I arrived home and it wasn't there. And so I went to the IT people and I said, look, I lost this little token generator. And they said, oh, no problem. Install this on your computer, on your phone. So I installed this thing, which is log in with biometrics. There, this thing here. And it generates a number for me. And all I had to do with this is I had to couple it with the computer system here, and then it works. And the banks use the same idea, right? So now all those old devices, we don't need them anymore because we can generate that. And of course, it's password protected. Don't think you're just going to pick up my phone and start, because you need my thumbprint as well as the number. Okay, how we doing? You guys getting tired? Can I finish the lesson? It's another 4 or 5 slides. It's okay? All right, so about wireless security. WEP, sort of when wireless first started, like 1999, 1997, they specified this standard for security of wireless. It had a 64-bit key, something like that. The key is shared. And so what do we have? We have all the computer scientists and all the universities around the world, not all of them. Some computer scientists and universities around the world said, hey, you know what? I'll bet we can crack that. And sure enough, after a few months or years, people came up with these, they would write a report and put it in a scientific journal, computer science journal. This is how you crack WEP. Well, that's kind of bad. So they had to sort of come up with something else, because what they found is that if you monitored all the traffic going between your access point and the device that's trying to access the access point, that you could do an analysis of that, and from that you could pull out the key. And so then when you had the key, you could crack the encryption, you could see all the packets, what's inside them. So WP was not very great. And so they came up with something else. Now, as it says there, it had 2 forms of authentication: open system authentication and shared key authentication. And do we talk about that? No, we don't. That's all right. So as we progress through these slides, we won't go through them in much detail, but a little bit. So because the computer scientists sort of said, yeah, we can crack this, look at this, it's in a journal. So anybody can read that, including the hackers, they can read that. And so they're going to be able to crack, you know, it's not safe. You know, they can sort of read your packets. So don't go doing your banking on an old, you know, Wi-Fi that's using WEP. So they came up with a sort of a fix, and as it says, it's a temporary fix, a TKIP, which had a better management of the key. So they use a better key. And so instead of a 64-bit key, they went to 128-bit, I think. And that sort of worked as an interim. But even it had some issues. Again, the computer scientists, you have to, now you might say, well, why would a computer scientist go and spend some time trying to crack somebody's, you know, encryption? Why do they go to all that trouble, you know, just making the life of the hackers easier, right? Well, I think the idea is that the hackers are going to do it anyways. And so let's get the computer scientists in there to find out what's wrong with it so we can fix it. And so that's what they sort of came and did. And so WPA2 is a replacement for those ones and sort of has a higher standard. And so what it's got is it's got a special thing going on here, the CCMP, counter mode by a cipher block chaining, message authentication code protocol. So those things were added to our Wi-Fi. So as it says, it gives us a better security than we had with the WEP. So you have to say that the WEP, the security was lacking. And so we've sort of come up with these new sort of version to overcome that. And it also has an advanced encryption standard. And I think that's all. So there we go. Any questions on that? That was just a very quick sort of primer on security as it applies to networks. So what we did talk about, we talked about security involving firewalls, access control lists, right? Then we talked about what was the other things? We talked about our particular devices, uh, what do we call them? Detection, what do we, access detection lists? What were those? Sorry, can't believe I'm flaking on it. Let's come back. Oh, it goes so fast. Can't stop it. So we talked about our firewalls. Yeah. What was that one? It's just, yes, intrusion. That's the word I wanted. So we talked about, so we have these devices that will determine if there's been any intrusions just by looking at statistics or looking at particular patterns. And we have that will prevent intrusions. Likewise, looking at the patterns. And that we can put devices in a particular place for those. The DMZ, maybe I should have talked a little bit about that. Just here while we're looking at it, the DMZ. So what we've got is we've got this place which is not actually part of our network. I mean, it's protected from our network by a firewall. It also is protected from the outside world by another firewall here. That's not always the case. Sometimes you only have one firewall. But typically you're going to put a firewall on both sides of the DMZ. And so the DMZ, whatever devices are in there, they are separated from our network. So we're going to put in the DMZ the things where other people from outside world are going to access our network, and so that they're not having direct access to the network. So that's the idea of the DMZ. We can put our proxy server there as well. And so, yeah, that's basically it. I'm going to stop talking now, especially I couldn't even. And I'm going to let you guys go for a break, I think.